Alright, time for another DraftPhysics.com, debatephysics.com also. Video presentation. Fix the sound. Alright, back. Anyway, okay, comments, I guess. There really aren't any. And this is a big problem. Somehow this conversation about physics has to be stimulated somehow, and nobody will provide the platform for it. So there are no opportunities to discuss physics. Nobody has rooms to discuss physics. Nobody does conversations arguing physics. It's just nothing. That John Chappelle thing, does a little bit of it, but yes, I've been de-invited. But it's, there's just no place for this to be hashed out with people who know what they're talking about. So even in the John Chappelle thing, it's all a bunch of, flat earthers essentially, all people with agendas. And there's no real physicist in the room to point out the bullshit in what's being stated. And really, they're just all obsessed with Einstein's relativity and stuff like that. They don't even get the simple answer to destroy it, which is gravity creates heat. But anyway, so comments, and these are just they're just not useful. So there's just no place to have this discussion, unfortunately. Now I'm willing to have it, but somebody has to be able to show up and make arguments in some sort of rational, disciplined way. Arguments that have something to do with evidence, of course. So anyway. So this guy, it's nice or whatever, you're not on the subject, okay? At least someone with logic and integrity, your ephilism idea. So this isn't the right channel for that, fella. It's not this hard to figure this out, right? This is physics. I want to talk about fucking goddamn physics. You can't figure this out? Shit. It's just so annoying. But anyway, it's just the way it is. People. All right, so this Keith, the square earther. So, your channel name is already saying I'm just a fucking troll. That's what I do on the internet. I have nothing better to do with my time than just be an asshole. Fuck you. Jesus. In physics, force equals rate of change. So this is the same shit. We keep hearing this crap over and over and over, and it's just a waste of goddamn time. And again, you're interpreting this formula, which is perfectly rational, that force equals the change in your momentum. And if you put it over a time, then it's going to be a fucking rate. That's 9.8 meters per second per 1 second. That's the rate, you shit for brain. If you're doing a net force, the total amount of force, there's time is irrelevant. Shit for brain. And so it just ends up being force equals the change in your momentum. That's all that can possibly be transferred through a force is a change in your momentum. You can't transfer anything else. All right. Anyway, in layman's terms, fuck you. I'm a little past all that bullshit, fucker. All right. It's something you can measure with a scale. That's my whole fucking argument. That it's weight, you goddamn jackass. I've only drawn it 600 times. I put a scale. I know I have one right here somewhere. Come on, scale. You're right here. Newton's cradle. Yeah, I know the scale is here. Anyway, I put a scale going this way, and I bang something into it with a velocity. And that's the whole argument, is that, we can figure this out. We can figure out exactly how much momentum you're going into the Earth with, because we can duplicate your gravitational weight by just turning the scale sideways and seeing what your impulse energy creates as a weight. And then we know exactly what your momentum into the Earth is. Fuckhead, I've only made this argument 600 times. All right, so fuck that paragraph. Fuck this second paragraph, okay? If force equals blah, blah, blah. Yeah, it's a rate, okay? And then he decides to turn that into must equal the change in 1/2 mv squared. Where's this squared function come from? Where's this squared velocity come from? There's no squares here. So fuck you. All right. And then he ends with, if you understand this, you understand why objects going 5 times faster has 25 times the energy. There's no evidence of it, okay? You have no physical experimental evidence demonstrating that to be true. So fuck you. You're wasting my goddamn time. And I can do all this all over again. I keep pointing out that, well, the lever says exactly the opposite. Okay, there's no way you can make, these things that you say are the same thing. 4 pounds dropped 1 foot, 1 pound dropped 4 feet. Well, 1 pound dropped 4 feet is going twice the velocity. That doesn't work on a scale. Those two things don't weigh the same. You just use the word weight. It means something. The fact that those two things don't weigh the same means something. It means that that's not right. It's not correct. Shit. It's just such a waste of time. I mean, these people who, they profess to be atheist and against all this religion and bullshit and dogma, and all they are is about dogma. That's all they care about is asserting their doctrine. And saying we must all believe their doctrine. They prove nothing. They can show nothing. It's disgusting. All right. So that was it. Yeah. So not much in the comment section worth my time. So we will move on to a little video entertainment. I'll do a little bit on kinetic energy. The truth. I mean, there are just really simple arguments that demonstrate that they just will never be able to produce this evidence of this increase in energy by simple logic. So in Niagara Falls, gigantic turbines. I went to Hoover Dam when I was a kid. Gigantic, turbines. Hundreds of tons, moving. Of course, if this worked, if spinning something faster made more energy, then they would use very light, small turbines, a bunch of them, and get much more energy as a total amount of energy. They wouldn't be pushing big, heavy things slowly if pushing light things fast made more energy. Just a fact. So the bullet, in that case, the small turbine, doesn't have 2,000 joules of energy versus the gun's recoil having 2. There's not 1,000 to 1 difference. You don't gain anything by making it smaller. It doesn't happen in the real world. The bullet doesn't actually have more capacity to move matter. If I could theoretically tie a string to the bullet and tie a string to the recoiling gun and have a tug of war, the bullet wouldn't win. It has a tiny mass, 1,000 times less mass, and yes, it's going 1,000 times faster. So it has the same momentum as the recoiling gun. It has the same power to move matter. Okay, yes, bullets look like they do more work. It only looks that way. It isn't real. They break things better, period. That's it. They don't knock down buildings better. They don't do a lot of things better. But yes, if you want to fracture something or cause damage to a surface, they're really good at that. And recoiling guns really suck at it. But it doesn't mean one has more energy than the other. You fucking idiots. I can't, you're almost saying, oh, come on, I shouldn't have to explain this. That looks like isn't always is like. I shouldn't have to explain that to people who have any scientific literacy. But I have to. And it's just really depressing. All right, so this is an old 1956 video or something using the CO2 pucks. So they take a nice stainless steel smooth surface glass, who knows, and they make this little CO2 thing, creates a gas, floats the puck on the surface and creates a nice cushion, and things are fairly frictionless. Okay, so you can do isolated experiments and collect the energy and see what happens without something interfering. So it's a nice principle. So the whole video, this guy's talking about kinetic energy, and he's using 2 pucks that have exactly the same mass. So it's really just a momentum experiment, of course. You're conserving the momentum, the MV, And in the case where you don't change the mass, well, of course, you're going to conserve the kinetic energy as also, because you didn't change any masses anywhere. And it's only when you have a conversion that requires the mass to change and the velocities now will proportionally increase, is where you'll see the real truth, which is, yes, the momentum is always conserved, and the kinetic energy won't go anywhere. So he's arguing that kinetic energy is conserved in elastic collisions, and it's not, because he didn't do the experiment right. Okay, you got to do it with masses of different masses, and then you'll see the divergence. You'll see the momentum always works, and kinetic energy, depending on whether you're hitting light things into heavy things or heavy things into light things, completely fails. So I'll play a little bit of this.
On collision of the magnet pucks.
But, it creates this is an actual film of, they put a little spot on them and, shine a strobe light, and it's really quite a nice effect. You can see how much distance they travel in time. You can see exactly that, okay, this thing's going twice the distance between spots, and this one's going half, and so you can tell the velocities quite easily. Very nice experiment. Unfortunately, it's not going to tease any truth out, because he's not going to hit a 2 mass into a 1 mass.
Now I push the puck faster.
And you can see that this one's using magnetism, so you're storing the energy. So that's another trick that people think all elastic is all the same. No, they're not the same at all. Storage is quite different than what we would consider instantaneous contact and reflection. Those steel on steel isn't the same as these storage experiments. Not the same at all. You won't get the same results.
This time you see the strobe light flashing over a more glancing collision.
And so all the energy is just in the whole video is just pointing out that you can figure out exactly the distance between the magnets, and the distance between the magnets depends, tells you how much force you stored, and you just get back what you put in. So it's very proportional. It proportionally collapses the field, and then the field proportionally expands. But because it's pushing the same masses, everything turns out just fine, because there's only a total amount of spring pressure and you haven't changed any of the masses.
This is the stroboscopic photograph of that last collision. We get the same kind of record of the position of these 2 pucks in this collision as we got in the last collision. I've already analyzed this collision and computed the total kinetic energy of these pucks versus their distance apart, and found from that the energy stored by these 2 pucks in this collision versus their distance apart.
So he kept saying kinetic energy, kinetic energy, kinetic energy. And, he started off by talking about a momentum being conserved. And so the whole point of this video is to say, see, I've proven the kinetic energy is conserved. And the only reason why it's conserved is because he didn't change the masses. And if he would have hit things of uneven mass, there would be no conservation of kinetic energy. It won't happen. Ever, 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 ever. Okay. In the real world. Now, it can happen in people who fudge experiments and cheat where they can, but it won't happen in the real world. All right, so I shall do a little drawing, I suppose, to attempt to illustrate the point. All right, so you have 2 kinds of collisions. So if I bang something, steel on steel, all right, so these are 2 hard objects. They're going to transfer their energy. Now, we know if I make those, I have to fix that focus thing. Always something. Nah, it should be good enough. So if we have the same mass, we know that it's going to do the simple thing with all the energy, and this one is just going to be transferred to this one. But if I have uneven masses, something else is going to happen. And then we have this other experiment where you're essentially saying, let's have a spring between them, something that compresses, stores the energy, and then releases the energy. And the trick there is, is that it's not going to be this quick experiment. It's going to be an experiment that happens over a longer period of time. Okay, so you have a much longer time scale that the experiment takes place over in terms of the exchange. Same with the magnetic field. It takes time to compress into it, And as you're doing that compression, what you're actually going to do, in the case of the pucks, illustrates it quite well, is there's a whole period where the field gets compressed and the whole thing is starting to move. So you're moving the spring. So that's the trick with when you're using some kind of compressible that takes time to transfer the energy. That is, it has to compress and then it has to expand. And we're not talking about electrons. We're talking about a whole length of material that has to, we're talking about billions of electrons having to move for you to do this feat of storing the energy. And so then the transfer will be completely different, because what you've done is you've started to give, like say this thing had the motion and it starts moving this object while it's still compressing the spring. So the entire spring is going to move with the object, essentially. So you're changing the position of the spring. So you've moved the whole mass of the spring, essentially. Moved the whole experiment in a direction mechanically. And so you've given this one an x velocity before you've even completely compressed the spring. Then the spring expands and gives an equal amount of momentum to both sides, but it's an equal of some 3/4 of what's left. It's already given away some of the motion, and so the amount of motion the spring is compressing is smaller than it would have been if the object didn't move. But because the object could move, that's why. And so you get these very different results. So if I bang the light thing into the heavy thing, the light thing bounces off. Okay, and if I bang the heavy thing into the light thing, well, then the heavy thing doesn't bounce off. It keeps going and it moves the light thing. So it moves whichever one has more momentum in the experiment. Okay, it'll tend to put more energy in that direction. Okay, and less energy in the opposite one. So you won't get an equal and opposite reaction. So if you do these experiments with a spring, you're not going to get with uneven masses. You're not going to get necessarily half the momentum in one direction, half the momentum in the other direction. What you're going to get is half the velocity in one direction, half the velocity in the other direction. And that's what you see with the Newton's cradle. So in the Newton's cradle, you have this circumstance where you have all the energy in this very light thing. Okay, it hits something, say, 3 times this heavy. And what happens is both objects go the same velocity away. They don't have the same momentum. This one has 3/4 of the momentum, obviously, and this one only has 1/4 of the momentum. So it doesn't turn out that you can't just say that this is the law of an elastic collision, because the elastic collisions are very different. So back to the one with steel on steel, this one happens really fast. So these transfers are not moving the experiment. So what you will get is the same momentum going this way as you have this way. So if you do the experiment metal on metal, you'll get one result. And if you do the experiment with a spring between them, you will get a different result. It'll be mechanically a different experiment. And so they just say the word elastic. Both of these are called elastic. I mean, this is technically super elastic with the spring, but they're both considered elastic collisions. And they're really not going to be functionally the same, and they're not going to obey the same rules. Okay. So maybe it's worth talking a little bit about the fact that, if you do these experiments, you don't get, the non-reversibility, which is, again, kind of the simple way to attack relativity, is that it really isn't the same, going one way with the energy versus going the other way. Because one way has more energy than the other way. All right, I'm back. Here's the simple diagram. If I have the 3 mass hit the 1 mass, okay, then I'm going to end up with 2 things going in the same direction. Yeah, their distance between each other is going to separate, but they're still going in the same direction. Okay, they both have motion in the same direction. And if I hit the 1 mass into the 3 mass with, say, the same, I just make it more aggressive. It doesn't matter. I can have the same momentum. the momentum is going to be conserved in both cases, but what's going to happen in this case is, yeah, the light mass is going to reflect, and the 3 mass is going to go forward. They're going to be going in opposite directions. So this isn't, there's no equivalency principle here, in the sense that it does matter which object is actually moving. You could argue that this is almost like a Newton's bucket thing, telling you, yeah, one of these must be absolutely moving, because there is a difference. Somehow these objects know that one of them is doing the actual moving, because the 2 experiments come out differently. Their difference, okay, this is different. This hitting this gets a different result than this hitting this. So I'm just saying, then, yeah, so where's the relativity argument here? Because the 2 won't look the same. It won't be irrelevant whether you hit the piece of dust or whether the piece of dust hits you, okay, with the same momentum. The outcome will be different. And if I put a spring in there, I'm going to get even a different result. So if I do it with steel against steel, I'll get one outcome. They're still going to be different outcomes. And if I put a spring in, I'm going to get even an more exaggerated, in the sense that this 3 mass will leave with more energy than it would without the spring, because it's actually going to be pushed as the spring compresses. It's going to move as the spring compresses, and then the spring is going to expand after it didn't fully compress because the object yielded. If the object yields and starts to move before the spring is fully compressed, then it's going to have more energy, because the spring is going to be giving half the energy when it's only got 3/4 of its energy left, is the simple argument. So they're different experiments. There's all kinds of subtleties here, and physics pays 0 attention. Just couldn't care less. And all of the defenders of physics couldn't care less. They're important variables. You know, this is all the way going back to the fact that they don't want to hear the argument from angular momentum. So when they do their little silly cart experiments, banging carts into each other, they don't want to hear about the absolute real fact, okay, that I can give a cart a velocity, okay, and this velocity it has won't be its total momentum in hitting a brick wall, for example, because the rotational energy stored in the wheels and the axle, all of that energy is not linear. It has no linear component. All right, it's obviously going up, down, sideways. It's circular. It's trapped in a flywheel, essentially. These are essentially 2 little flywheels, okay, attached to the car. Okay, they have stored energy, and so when it hits the wall, they're going to be converting their energy into motion in one direction, because they're obviously going to be pushing, even when they're pushing up, or it doesn't matter which way they're pushing. The fact is they're going to be pushing against the ground decidedly in that direction, which means the cart is going to have pressure in that direction. So you could measure its velocity and its mass and say it has a certain amount of momentum, and guess what? The answer is wrong. Okay, the amount of momentum it has is not only its linear motion, but any angular rotation that's caught up in the cart. And the simple argument I've made, for which there has been 0 rational response, is that you have to consider that, because it's a huge difference in how much energy you're going to be storing in those wheels. So, what the hell is that? I obviously hit something. Don't know if it matters to you, but it mattered to me. Anyway, here there was a disturbance in the force. Anyway, so where was I? Yes. So if the cart, you can understand that the faster I make the cart go, okay, the more energy I'm going to store in the wheels. And the slower it goes, the less energy stored in the wheels. So if I can make this car go twice as fast, you can understand there's now twice as much energy. So whatever the factor is, it could be 10% of the energy is in the wheels. Well, now it's 20% at twice the velocity. I'm going to keep increasing how much energy, total energy, is in the wheels versus how much energy is in the cart. And so I can't make some comparison between the cart going 10 velocity versus the cart going 20 velocity without considering the fact that the linear motion, the cart going faster has stored more energy in the wheels. So it's going to deliver more energy because of the extra energy stored in the wheels. So it's not really a fair comparison to say, oh, here's this one's 10 times more massive, and this is only a 5 mass, and say it's equal, because no, I'm cheating the argument. I should make this, I should just make this the 5 mass versus the 10 mass. And so I have a 10 mass going 5 and a 5 mass going 10. And you can understand that if I have those with wheels on them, I don't really have the same momentum, because this cart has more energy stored in the wheels. The faster cart's going to have more energy in its wheel train. Just a fact. So it's a cheat. So when I bang something into here, I have more energy than I thought, because I didn't calculate the amount of energy in the wheels. And so when I hit something, I'm going to end up giving it more linear velocity than I thought, especially when I hit a heavier thing, because I'm not going to have as much energy in the wheels this time. And now it's going to go faster than it should be going, obviously, because it's using that extra energy that was stored in the wheels. So it's a real thing, and they don't acknowledge it or pay attention to it as a real variable. Even though, like I said, when you double the velocity, you're doubling the amount of energy stored in the wheels. Yeah, it's probably going to be a significant effect on the outcome. All right. So that's probably enough. I'll give it a think and see if there's anything else I got to say. But very discouraging. No, there's just no rational response. This is just... I'm just amazed that, say what, the last video got 200 views, the one before that, eventually they get 200. And out of those 200 people, there's not one single person that has any kind of physics education that is willing to say, yeah, these are good arguments. They really should do more experiments, because they really haven't proven shit. They really should have a, 10 mass going 5 versus a 5 mass going 10 and do the tug of war and film it and just show everybody that, yeah, no evidence that the 5 mass has twice as much energy. No evidence whatsoever. That all these experiments should be done. Again, the giveaway is look, they already know this. They can't make any kind of device, any kind of ballistic pendulum that can actually collect anything more than 0.06% of the kinetic energy of a bullet. 99.94% of the kinetic energy is missing, and they can't do any better than that. The transfer can't do any better than that. It's like saying you have a bucket of water and all you can get out of the bucket, the only water you can hit, you could throw somewhere, is 15 drops. And that's all you can do. I mean, obviously ridiculous. So this claim that there is all these joules of energy is just that, a claim with no evidence. It might as well just be called the Holy Ghost formula, because it has no credibility. 1/2 mv squared is never conserved in any experiment where you change the masses in which the energy is going to be transferred. So anytime you attempt to transfer the energy to something with a different mass, you will not transfer the kinetic energy. It will fail every single time, because it's not real. It's just a fable. It's a catastrophic mistake, and an obvious one, and they're denying it. See, at least they admit that Benjamin Franklin mislabeled plus and minus. They admit that, yes, it's stupid. Amperage and voltage have to be going in the same direction in a wire. It's just ridiculous to say the amperage is going in the opposite direction. It makes no sense. It's silly. And they'll admit, okay, they made a mistake, 200 years ago, and it was just too much trouble to fix it. It was like the whole Fahrenheit Celsius thing, when frankly we should just be doing the Kelvin thing. I mean, it really does make sense to understand there's no such thing as a negative temperature. It's just a ridiculous, silly kind of notion. We all should be way past being fooled by that. And the fact that physics doesn't even say that clearly, that there's no point in measuring in Celsius or Fahrenheit or any of this crap that has a negative number. There's no such thing as a negative temperature. It's just ridiculous. It's all positive temperatures. Things that are insanely cold are still quite hot. That is the truth. Damn. I mean, being 100 Kelvin is putting you at somewhere around minus 200 Celsius. I mean, or whatever, minus 500 Fahrenheit. I don't even know what the minus number in Fahrenheit is. And the fact is, it's not a negative amount of heat. It's a positive amount of heat. It's just a very little, but it's there. It's real. And they don't fix that. And then here's the MV squared, and they won't even admit it's broken. I mean, it's catastrophically broken. It's silly and nonsensical. It completely breaks all kinds of coherency. There's no such thing as scalar velocity. It's just velocity without a direction. It's retarded. Doesn't make any sense. Energy without a direction. It's nonsense. And they just won't own up to it. And it's, but it's everywhere. I mean, the fact that just no physicist has ever uttered the words, as far as I can tell, that gravity creates heat. I mean, no one's ever suggested that that might be a possibility, that gravity actually makes things hot. Huh? I mean, if somebody would have said it to me 10 years ago, I would have said, shit, yeah, of course it does. I mean, obviously, the pressure just goes right in through the earth. We're all pushing pressure into the center of the earth. Of course it gets hot. Of course. It can't help but get hot. Just amazing. But anyway, it's just the way things are. I suppose we have some little intuitions that, that mess with our brain, because we think of, like, if you think of the high pressure of the deep ocean, it's pretty cold. But it's actually not pretty cold. It's pretty hot on the real Kelvin scale. It's pretty hot. Okay, so we think, oh, there's no energy down there. No, there's plenty of energy. All right, and it's being dispersed into a ton of mass, and so that's why the heat that's in the core of the sun in a small area has to be spread over the gigantic substance of the earth to get out. And so by the time it gets to the surface, it's been fairly diluted in its intensity, you could argue. So it goes from being 4,000 degrees in the center to being maybe just 150 Kelvin at the surface, which is minus 50 degrees or something. As the Earth's radiant temperature. Now, the fact is, though, the crust complicates things because of the plates and the lava running underneath the plates and all of that stuff. But, the fact is that the Earth does get warmer as you go into the ground. Anyway. All right, so that's probably enough. But, I mean, this is so depressing and disappointing that people are so corrupt and dishonest that they'll defend absolute nonsense and call themselves scientists, science lovers, truth seekers. And then they're not seeking anything but a defense of a God theory. They're just religious kooks. Creation science, that's all science has become. It's all just creation science, and the creator is Dr. Wu. They just like wooey stories. That's all it is. There's no God. There's just the Holy Ghost. That's it. Their God theory is a silly formula. Pray to the silly formula. The silly formula will save us. Anyway, so depressing. So, No, it's New Year's. I forgot about that one too. Yeah, so yeah, I have no resolutions. Hate the planet a little bit more, maybe. You know, I'll try to hate being on Earth a little tiny bit more. God, it's just so depressing. All right, I'll just have to endeavor to persevere. There's nothing else I can do. All I can do is attempt to reason. And when intelligent people won't be reasonable, game over. You know, then you're really fucked.